Okay, let's take a look at the technique or the method or the skills used to make use of an air diffuser performance chart. This particular one comes from Hart Cooley Engineering Design Manual. Here's the address for it. And you should know that there are 4 things that you have to balance in a design. Okay, use my cool little thing here. And so you're never going to get anything that's right exactly on. So you just need to get the best choice that gets you close on all 4 of these criteria. And you're going to have to scan the entire table to find a few choices that are going to do that. And then you'll choose the one that you think comes the closest overall. It's literally impossible to find one that matches exactly on all 4 of these. So the first one that we want to look at is noise level. And the way this table is set up by noise level, NC20 to NC30, and it says the noise level here. But any choice between these two is good. So there's a whole section of the table that's in that range. And so we're only going to look at data for us that's in that range. There are cases when you need it to be less, and there are cases when you can accept more. But those aren't the cases we're going to use. Those are the cases for real pros. We're going to keep between NC20 and NC30 noise levels. So that's the first thing to do, is we want to choose always in this range between the two. Now, I've only got one selection shown. That the data table has tons of them, but I'm just taking one. The next thing you want to do is get something close to the CFM that you want. Okay, so you should have been able to calculate from Revit the CFM per square foot and know how many square feet you're looking to cover with this air terminal. Okay, and so CFM per square foot times square foot is total CFM. So that's cubic feet per minute of air blowing out of the air terminal. So the next thing to do is try to find one where these numbers here are somewhat close to the numbers you're looking for. So in this case, I'd have, if I chose this one, I'd be operating at NC20, and I'd be able to deliver 133 cubic feet per minute out of the air terminal. And I'm using one with a duct that's 6 by 6. They're more interested in the duct than in the actual face of the terminal. Okay, so we want one with a duct that's 6 by 6 here. Okay, so again, attack the noise level, find some samples that have near the correct CFM, and now we have to balance 2 of these at once. Throw, how far does the air travel from the air terminal at 150 feet per minute. So it comes out very fast. It comes out like it's 700 feet per minute, but then it diffuses and spreads out. And by the time it's slowed down to 150 feet per minute, this one will have gone 9 feet. So from the air terminal, sideways and down, as soon as it hits a wall or something like that, it'll bend down. So the sideways distance plus the downward distance. This one will do 9 feet by the time it peters out from 700 feet per minute to 150 feet per minute. So we use the middle row because that's the most common type of diffuser. The middle row. And we look at the far left one. That gives us 150 feet per minute at 9 feet away from the diffuser. Okay, so this one we could say would give me NC20. It would deliver 133 cubic feet per minute, and it would give me a throw of 9 feet at 150 feet per minute. And so then I could use this air terminal, if that matched my requirements, for a 6x6 duct. There we go. That's how you do it.